Okay, welcome everyone to this video. Today we are going to talk about how to use Techlog to calculate the volume of shale. Okay, so uh, I'm using ChatGPT as an explanation, but then we're gonna go see how we can do it in the software. Um, Please, guys, have in mind that I am a learner. I am a student and I'm trying to get better at using Techlog. So we can all learn together. So if you have any advice for me, please feel free to comment down below, and so that we can all learn more and continue, this journey of becoming more proficient at Techlog. So as you can see here in ChatGPT, there are many ways to calculate the volume of shale in Techlog. We have different methods like the gamma ray method. We can use the linear equation. We can use Larionov method for older rocks, for tertiary rocks, the Clavier method, and also we can also use some other methods like the Sunny log, using the linear relationship between the transit time interval transit time in a clean formation and the interval transit time in the shale. Also, we can use the density logs method, the nutrient density cross plot method, which is a combination of the nutrient density logs, cross plotting them to estimate V shale. This is the formula. And also there's resistivity methods, as you can see. Okay, so here we are going to see how we can do that. So first of all, here I have in the import part of this software, I have a test well, and I have some logs to work with. Okay, so we're gonna start importing those that data set into our project so that we can start working with them. So we are going to check our logs. This is the gamma ray that we're going to use, and also we have the neutron porosity, right? And we need the density log, which is this one. Okay, so I guess we're going to be working with those at the moment. Okay, so first of all, you guys, in order to do that, we already have the logs, so we go to the petrophysics panel, okay? And then we can find in this section, we can find the different methods, individual methods or a combined method. So in this video, we're going to be using the very basic methods, which is gamma ray, neutron density, and go from there. Okay, so let's start with the gamma ray one. So we gotta make sure first, before using this uh, tool, that the family unit, the family and the units are okay. So we're gonna be using gamma ray. So the family of this data set is gamma ray. Okay, neutron porosity, bulk density. So it's okay. So once we check that, then again we open the gamma ray, and then we look for the family that we want to use. In our case, for this specific method, which is the gamma ray method, we need to use the gamma ray family. So we pick the gamma ray family, and then we click here to let the software know that that's the family that we're going to be using. Okay. So then once we click on the method that we want to use, the workflow manager is going to open. Okay, so guys, also we need to create some sonation, because you know in a well there's different formations. So let's go ahead and create a couple formations so that we can apply our workflow manager onto different formations. So let's see, we can decide, let's say, oh, I mean, from let's say that from 3,500 to 4,000, we can create a sonation. So let's call it formation A, for example, which is going to go from 3,500 to 4,000, for example. And then we are going to have another one, formation B, which is going to go from 4,000 to 5,000. Actually, sorry, we have to create a sonation name first. So let's call it formation. Let's speak, let's take the correct unit, which is fit. And then again, now we have to do it again. Once we create the sonation name, we drag the well, and then again, we do it the process again. We call it for the first one formation A, the second one formation B, and then we can fill the depths for the top and the bottom of each formation. This is just an example, so I'm just making this up. Um, Maybe later on in another video we can use real formations. Also, there's a way to upload sonations using an Excel as a CSV file, but that will be covered in another video. So once we have these formations in the zone editor, we go to the zone editor panel, and then we save this formation so that we can have it in our data set of you know, where we have our data of the well that we are using to practice with. Okay, now once we save the file and we see then in the project browser, then we can close this one because it's already saved. Okay, and that's the formations that those are the formations that we're going to be using. Okay, so in properties we can here what I did was just to add a sonation track, and then on properties with F4 you can go ahead and activate the formations. Okay, here in current zones. Okay, so we have the current zones, we have our gamma ray, our neutron porosity, and density locks. Okay, so now let's go back to the workflow manager that we already said that we were going to use, and here we can drag the inputs that we're going to use, right? So in our case, we're going to be using just our gamma ray lock for this specific method, right? So we can erase the first line, can remove it, and our input is going to be basically our gamma ray lock, which we make sure that we're picking this one. Okay, on sonations, we have to go to Global Sonation tab, and then open the formation if the formation zone that we created, right? So with this option, we can include those formations into the workflow manager, and that's where the analysis is going to be done, or the we're going to calculate the visual curve on those formations. And then we're going to have to define certain parameters so that the formula can be, the formula needs these parameters as we saw on ChatGPT. So the linear equation, for example, method requires you to have the maximum log of gamma ray, the minimum log, and also the logging of the, yeah, basically the maximum and the minimum. So you have to locate which is your clean sandstone or your shale, where the gamma ray of the maximum and minimum. So that's what we're going to use to do. There are many ways to do, well, not many ways, just two ways basically to do that. You can manually insert the values if you already know the values of the matrix and the shell, or you can use this method um, to do it with this tool. So first we're gonna decide. First we're gonna use the linear method, right, on both formations, and we're gonna click on display. Okay, just just to see what the result is here. This is a um, this is a result, primary result that we get, but we can modify it, right? We can change the parameters. So here, as you can see, we have an option to um, on this option, display current layer parameters. We can display the parameters in our track where we have the gamma ray. Okay, and then we can move the parameters. We can decide where we want to have our minimum gamma ray read, and what's going to be our maximum gamma ray, where the formation has more clay. Okay, so you can do that manually and then compute again, because as you can see, once we as we are moving this line, you can see here that this value is changing, right? So if we change these values and we run the model again, then this curve is supposed to be changing, right? For example, if I move these two lines here and then I compute it again, this is the result, right? But if I put these two lines all the way to the right side of the track and we calculate that again, well, we have no shell. Oh, so and also if you don't wanna keep doing this, you can just activate this. You can enable the automatic launch, and that is going to allow you to, as soon as you move the line, then automatically the computation is going to restart. Okay, and we can do the same for our formation B. Okay, so that is the way to do that. Now, if you have data from laboratory, for example, DRX data, then you can use that data to load it here and calibrate your visual curve according to your laboratory data. Okay, so we have uh, created a visual using the linear method and a gamma ray curve. So once we are satisfied with the parameters that we have and the linear method that we're using, then we can go ahead and save. We can save this curve so that we can have it as a new curve in our um, uh, project browser. So we go ahead and click on the curve that we just created, and we click on save variable, and then as you can see here, we can change the name, but we're gonna basically let it like it is, like VShell gamma ray. We can actually add the method, linear method, if you want. If you don't want, that's okay, that's on you. But this is just for me to be able to identify which method this visual was calculated from. Okay, so the name must not start or end with a space. So that was my mistake. We have to erase, delete the space, and then proceed to save the file. So as you can see here, we already have our visual gamma ray with the linear method. Now, we can close this tab, but before we do that, we can save our workflow. But before we save our workflow, we have to make sure that we save the workflow parameters that we use, right? So if you want to give this workflow to another person so that they can, you know, redo or reconstruct your visual with the workflow manager, they can do it because they have the parameters that you used for calculating that curve. So that's what we're going to do. We're going to make sure that we save the workflow parameters, and then we click on all of these aspects so that we can make sure that everything is been saved. The sound parameters, well parameters, project parameters, and also the workflow parameters. So when we say that, we have to make sure that in our workflow projects, this workflow is being saved. So here you can see if I close this workflow manager, by double clicking this one that we saved, we can see that we have it here and the parameters are there. So we know that um, our workflow and our parameters are completely saved. Okay, so we save the workflow and we can close. Well, the layout we can save it. We go ahead and multi-well layout, and then we go ahead and save the layout as, and you can just give it a name and save this layout, because this is where we are comparing and doing the quality control of our initial logs that we were going to use. So logs for Shale. Okay, so we already this workflow layout, we don't really need we don't really need to save because we already have the parameters. But let's go ahead and save it just for making sure that we are not forgetting anything. Workflow use visual uh, linear method. Okay, so we have our layouts. We have um, the layout that we got from the petrophysics gamma ray individual method. We have our layout saved. We have the workflow saved. We have the curve that we generated saved here. And now we can proceed to generate another visual, but using a different method. Okay, so we go ahead and open the neutron density method. We can either create a new workflow, or we can open the workflow that we were working on and add here another workflow for the next method that we're going to use to calculate another visual. Okay, so let's do this. Let's use the same workflow and save all these workflows within the same workflow manager. So let's go ahead and create the neutron density, but we have to make sure that we have to pick the correct families. In this case, we're going to be using neutron porosity, which is this one, and density. So we have to make sure, well, ball density. So, and then we go ahead and create this. As you can see here, now we have two workflows in this workflow manager. We have the gamma ray one, which is the one that we already did, and now we have the neutron density. So we check that the inputs are okay. We're using the we have two options, so we have to check which one we're going to use. So let's go ahead and take a look real quick on which of the two we're going to use. We have either neutron porosity and neutron porosity merge. Uh, I think, yeah, I think we have to be using, I'm not really sure here. Those two seem to be similar, but yeah, you have to decide in the data that you have which one is the correct one, or which one is the one that you have do the quality control, that you know for sure is the final version of the log with all the quality control checks. Okay, so for this example, we're going to be using the neutron porosity without merging. Okay, so this one is okay, and now we're going to check for the, we have only one option for our ball density log, so we check that the units are okay, family is okay, so this is okay. Now, yeah, as you can see, this one family is kind of like not okay, because it says resistivity, and we can see that the unit is for density, so we can reassign family and uh, choose the proper family for this one. Okay, so we did that. Now let's continue with the visual for with the neutron density method. So for this one, we're going to, we already know that the inputs are okay, these two, and now we're going to go for sonations. We're going to keep using the same sonations. We have two wells, as you can see, two formations, formation A and formation B. And now let's go ahead for the, let's go for the third tab, the parameters. So in this case, we have to decide on the density for the matrix, the density for the shell. You gotta make sure the density of the fluid as well. This is dependent, of course, on your case, the specific case that you have. But also we have to let the program know which is what is the neutron porosity of the matrix, and the neutron porosity of the shell. So the clean sanction and the portion of the reservoir that has more like a lot of clay. So if we're not sure how this method works, we can always press F1, right? And then we're gonna open the help section. And as you can see, there are some default values for the neutron porosity of the fluid. You know, if we have 100% water. Also, we have default values for the neutron porosity of the shell, the neutron porosity of the matrix. But you can, this is the formula that the program is using, but you can always use the cross plot. For example, you can display the neutron porosity and density cross plot, and then manually you can pick which is going to be the neutron porosity of your shell, and which is going to be the neutron porosity of your matrix. You know, the clean part and the clay part. So let's go ahead and open the cross plot, and let's go ahead and try to modify the parameters that way. So for doing that, we have to click on this option, which is display crossplot neutron porosity bulk density. So once we click on this crossplot, then we can, you know, always make it bigger here. So we can see that we can move this neutron porosity and bulk density of the matrix and also the shell, right? So let's make sure that we do this for one formation and then for the next. So we go for first for the global sonation, right? So we just filter for the formation A, right? And then we try to adjust to our data. We choose our matrix density and porosity, and then we also make sure that we have the proper again, you have to be an expert, right, to be able to decide where exactly these points should be, right? But this is why we're here. I mean, I'm not an expert at that, but we need to study our data and the theoretical values and make sure that we are choosing a value for the matrix and a value for the shell that makes sense. Okay, once we, let's say that this is the proper adoption of the values, then we go ahead and do it again for the formation B. Okay, and once we make sure that these values are okay, then we can proceed with the workflow manager, and we can tell that these values are different because we decided with the cross plot where they were going to be on each formation, as you can see here, right? And switching between formation A, this are the parameters, and formation B, those are the parameters. Okay, once we finish on deciding which parameters we are going to use, we can go ahead and display the values, the display the visual computation. So this is the result for formation A, and this is the result for formation B. As you can tell, if we enable the automatic launch system, then we can change. We can see that as soon as we change the values for formation B, right, then we are modifying how clean or how much clay we have in our reservoir, right? You can see on the right side how these modifications affect the end result. Okay, so this is where you have to do some calibration with lab from the laboratory. Okay, now let's go for formation 8 and see how it changes depending on the values. For shell and matrix, we are making the reservoir more cleaner, or we're making it more with more clay content. Okay, once you are satisfied with the results, you can go ahead and save this curve as the V shell with the neutron porosity method, right? ND, and you have it here. Now we can you can save this crossplot multi-well if you want. You can save it. Save the crossplot neutron porosity, density, V shell computation. Save this, and you can also, well, this workflow also you have to save and make sure that all the parameters are selected. And this is the neutron density method. You save it. We saved it. Well, now we changed the name of the workflow. So now you know what? Let's cancel this and save the workflow manager, because we have two workflows here, the gamma ray linear method and the neutral density method. So we have to save the workflow manager. You see, we have here yeah, we have the two workflows. Yeah, everything is safe, so that's okay. Okay, so finally we're going to, well, we already have our results. You can say this one if you want. Workflow. This is not linear method, but this is the ND method, visual for by neutron density, and this one was already saved. And now we can calculate another one. Okay. So for our last method, we're gonna use the Larionov method. So you already know the process. You go ahead and open the individual method, gamma ray. We already have the family, the correct family gamma ray, create. We go ahead and bring our data set, or well, you already know that this one you don't need. So we remove this current line. And now you bring in the formations that you're going to analyze. So you go to global zonation, you pick the formation zoning, you click the formations that you want to work with, and you click on this option, which is insert zones from the suggestion doc window. Then for this one, we're going to use the Larionov method, older rocks. Okay, so we already picked the method, we already have the formations, we already have the right input, which is the gamma ray curve, and now we are going to click on display. Okay, and again, as you can see, you can always click on the display current layer parameters and click on the enable automatic launch to modify those values according to your formation, right? You have to make sure you click on the minimum value of gamma ray that you have in your log and the maximum value you have, right? Obviously, if you have expertise, you know your reservoir, you can, if you have data from laboratory, you can adjust and calibrate, and based on your experience, you can make it better. So now here we do the same for our formation B. And once we are satisfied with our results, again, we can save this variable, and this time we're going to save it as gamma ray Larionov method. Okay, so that was the video from today for today. Sorry, and I hope that you learned something. And again, I'm a learner as well. I'm a student as well. I want to be able to know more and practice more. If you have any tips or if you have any advice, I would really appreciate the comments. And I hope that we can continue on to learning more about how to use Techlog for analyzing wells, formations, and I hope that we can continue on this journey together. So have a good day, rest of your day, guys, and see you the next video. Bye bye.